We have seen curl in calculus. Now it's time for flux in calculus. Curl in calculus, flux in calculus. Curl, flux. So what it is? So curl, we have seen that if I have a algebraic vector, vector field, not a static vector. If I have algebraic vector that is vector field, then it's line integral. If I have a vector field, then its integration along a line. I mean multiplication with the line. Integration is nothing but multiplication only, right? If two items are multiplied, then it is simple multiplication. But if two algebra are multiplying, then it is varying. In that case, it is integral calculus. What is two items are multiplying? Two items when they multiply, they typically give the area of a rectangle considering the two items are two sides of rectangle, and that is the place the integral calculus begins, primitive calculus. So when we have integration requirement for the algebra, then we have integral calculus. If I have a vector field and I want to, if I have a vector and I want to multiply with the displacement, then since it is a vector, we go with the dot product. So we go with the dot product of the vector and then we get the multiplication. First find the effect, find the effective vector along that direction. If this is the vector field and this is the direction, this is vector field, this is the direction, and what is the product of this vector along this vector dot this vector. So first find this vector's effect along this direction, that is f cos theta. If capital F is the vector field, then capital F cos theta. Capital F cos theta is the effective vector along the displacement direction, where theta is the angle from displacement vector to the vector field, that is the theta. This vector field cos theta is the vector field along the vector field along the displacement direction, or capital F dot d vector r vector. But if it comes as a vector field, when r vector is algebraic vector and vector the vector we are talking about, the numeric vector, static vector, that is also a vector field, capital F dot dr vector. So now it is algebraic. Algebraic means vector field would keep changing if I change the independent variable, because it is algebra. What is the value of sine 30? What is the value of sine 30? It has some numeric value. So sine 30 altogether is a constant. What is value of sine x? Now it is algebra. Now x keeps changing and sine x keeps changing. Like that, if I have a vector 2i plus 3j, what is that? That is a static vector. What is 2 plus x plus yi plus x plus sine yj? Now it is variable vector depending upon the xy coordinate. So if I have a force field, if I have a force field that is a vector field and displacement also a vector field, algebraic vector, then what is the net multiplication? That is force field dot d r vector, that is r is the displacement. This is what we have seen in the curve. This is also called line integral. If I have a vector field, then vector fields multiplication along the displacement, or vector fields dot product along the displacement, or vector field integration along the displacement. This is called line integral. The vector fields integration along a displacement is also understood as line integral of the vector field along the line, or along the curve along the displacement. Very nice, right? Miss, I understood. If you tell someone, then he would reply that I understood. Okay, you understood, right? So now you understand that line integration, the line integral is is line integral divided by the area in a closed loop, that is the curl factor. What is surface integral? I don't know. What is surface integral? I don't know. Okay, so that is something that someone is saying it is new to me. I don't know what is surface integral and it is new to me. If this is vector field and this is line, then this vector field's integration along this line is called line integral. If this vector field is capital F, then F cos theta. Now this effective F along the line, F cos theta into the line, or F dot vector with the line vector. Calculus F dot D line vector, dr vector. Now it came to surface integral. No, it is not line integral, surface integral. If this is the vector field, algebraic vector, and this is the surface, then what is, if this is the surface, then what is its line integration, what is its surface integration along the surface? Curl factor was line integration, flux factor is surface integration. If that is the case, then if this is vector field capital F dot d a vector, there it was dr vector, here it is d a vector. Capital F d a vector, capital F dot capital F on top of it one arrow mark that symbolizes vector field. Capital F dot dA vector. What is A vector? A vector is, if this is area, then direction of the area. Okay, direction of the area. So a direction of this area is perpendicular to it. See, the direction of the area is changing like this. This is direction of the area. This is force. Force, this is a vector field. Vector field dot d a vector, capital A vector, integration along this surface. This is called area integral, surface integral. Earlier we had line integral, that was curl factor. Now we are into flux. What we would get? Okay, very nice. Now introduce something called surface integral. If I have a vector field, algebraic vector, and if I do dot product means along the area vector, surface vector, then I would get surface integral. Very nice. I mean capital F dot d a vector. If I do capital F vector dot a vector, then what is expectation is F and A vector are the static vector. Then also it is alright. But if they are algebraic, since they are varying at every moment, then it is D A vector, not A vector. If it is A vector, alright. I have an area, this is a circle, and whose radius is 2 centimeter. This circle radius is 2 centimeter. Then what is its area? Pi r square, 4 pi, in direction of x-axis. It is kept like this. It is kept, this is x-axis, this is y-axis. It is kept like this. If that is the case, then it is 4 pi is the area and direction is I vector. Now force is 2I plus 3j. This is example I am taking. 2I plus 3j. I mean this is not force, this is vector field. Consider this vector field is 2I plus 3j. I am talking about surface integral. First let's calculate the simple vector multiplication. So if vector is 2I plus 3j and area is 4 pi I vector, then the net you can say the surface and vector field multiplication is 2I plus 3j dot dot 4 pi I. J is gone and it is 4 pi into 2. 8 pi is the net multiplication. What it says? Consider that there is a flow of water. There is a flow of water and it has velocity as 2I plus 3j. Come on, velocity cannot be 2I plus 3j. Tell me something, some number. Then it is 2 square plus 3 square square root. That is square root of 30. That is the velocity you were thinking. But direction is 2I plus 3j. Tell me the direction one. Then 2I plus 3j whole divided by square root of 13, that is unit vector. That is the direction and it has velocity as a square root of 13. Very nice. Now tell me that through this surface, if that is the direction of a water, then through this surface which is oriented, this is oriented surface. If it is oriented along I-axis, then how much is the water that is coming out of this surface? Because water is flowing in this direction, how much is the water that is coming out of this surface per second? The volume of the water that is coming out of this surface per second. This is also called flux. Flux of the vector field, flux of the vector field along the surface. Okay, now here it is not vector field. Vector field is algebraic vector. Here simple vector. 2I plus 3j is the vector and surface is 4 pi. Pi r square is the surface, right? And it has radius as 2. So 4 pi is the surface. 4 pi I. So 2I plus 3j dot 4 pi I. So it constitutes as 8 pi is the 8 pi if that the velocity is 2I plus 3j centimeter per second. If that is the case, then net volume that is coming out of this surface, out of this surface is 2 into 2I plus 3j dot 4 pi I. J is gone. 8 pi centimeter cube per second. That much is water that is coming out from here. No. Can you maximize it? Certainly I can maximize. If you want maximizing it, then this was the water direction. Now tilt it along the I-axis only. Then you will get maximum throughput. If that is the case, then now tell me what is the equation of your water. Then it is square root of 13I. Because power is the square root of 13. Now direction is I. Square root of 13I. If that is the case, then net flux, net volume that is coming out of the surface is a square root of 13I dot 4 pi I in same direction. Now it is 4 into a square root of 13 pi, that much amount of water per second that is coming out. That will be the square root of 13 into 4 pi centimeter cube per second. It is bigger, far bigger than 8 pi centimeter cube per second. Tell me, my water is along j axis. So that is square root of 13j. Square root of 13j dot square root of 13a dot 4 pi I. 0. If water is moving in this direction and your surface direction is along I-axis, then no water is passing through the surface. Dot product has its own shining. Okay, where your calculus is coming into the picture? Certainly calculus is coming into the picture if the water velocity is not 2I plus 3j, it is x plus yi plus x plus sin y j. If that is the case, then it is vector field now. It's not simple vector. Because vector field is algebraic now. Every moment if you change x and y, the direction of vector, power of water and direction of water, it is changing. You can think something like, if like generally in the park you see there is a water coming out from some entity and it is rotating so that all the area grass will get irrigated. So it will rotate here and there. Consider that something is rotating like this and changing the magnitude of the water also. So that is vector field. Where if this is xy plane, if this is xy plane, or simple in 2D, this is x axis, this is y axis. Y is function of x. Okay, so if x is 1, then vector is like this. If x is 2, then vector is like this. If x is 3, then vector is. If you change the independent variable, vector keep on changing. So that is vector field. So very nice. Means if I know vector field dot area vector is the net throughput, or that is the flux, or that is the volume per second that is coming out of the surface. But if the vector field or velocity vector is now velocity vector field, algebraic vector, and the direction, the surface area is no more flat. This is surface area. Now, surface area is like this. It is kind of a hemisphere, hollow hemisphere that you can think of. Consider this as a hollow hemisphere. Okay, this is hollow. This is hollow. So, full is surface area. Full is surface area. Actually, surface area was like this. Then I went to some kind of a what the person who mold the metal, right? He will put the metal on fire and he will mold the metal. Black smithy or smithy, whatever it is, gold smithy, black smithy, copper smithy, whatever. So I went to smithy and it was flat and he turned it into like this. This is filled, but this is empty. Okay, so he turned it like this. Now what is the area now? Here if you see the you see the surface direction is completely changing. Can you see? And here surface direction is like this. Here surface direction is changing. Not required that surface is always flat. Surface can be oval, surface can be in dome shape, or surface can be in hemisphere, paraboloid, conical, whatever it is. Then everywhere the area vector is changing. Now the velocity vector is also changing, area vector is also changing. Then you can catch them with algebraic equation. Now velocity vector velocity vector is now velocity vector field capital F. On area is also a vector field. Now net flux that is passing through, if I have a velocity, if a water like this going like this, then how much is water coming out of the surface? Not only from here, from all around. Okay, if this water is flowing like this, then completely it is going inside this surface. Then water will come out of the full surface. How much is the volume of the water per second that is coming out of this surface? If the velocity is along the, it is in I direction. If velocity of the water is along I axis, where surface is varying, this one is along I axis, otherwise it is varying. Or velocity vector, if you everywhere, if this is the x axis, then this is the velocity vector. Okay, if you take xy plane, if you change it, the velocity vector will be like this. Here it will be like this. It is keep changing. If that is the case, still equation, abstract equation is same. Capital F dot E dot A vector, where this is dot dA vector. Capital F, that is the velocity vector field. Capital F vector dot dA vector. Okay. Now a vector is not constant as it is a vector field, and capital F, that is a velocity vector field, again it is not constant since it is vector field. Now integration now since it is calculus, I have to I have to do integration, and integration is all along the surface. So this is a kind of cylindrical surface, and then this is kind of a it is a kind of a circular surface. That much is the surface. So this surface, that is the A, and this surface. So all along I call it A vector. So capital F dot dA vector integration for the full surface. That is the net flux that is coming out of the surface where the velocity vector field is capital F. Capital F dot dA vector, capital F vector dot dA vector integration along the surface. Okay, so this is called surface integral. It is surface integral. If that is the case, then can someone prove it? This is actually the case, the surface integral. It is very simple to prove. It is not as difficult as a Stokes theorem. Now, if you have a surface like this, then take any small portion of the surface, that is dA, that is dA, and small, since I have taken a small surface, if I take full surface, then it has direction that is varying. If I take a very small delta area, delta A area, very small, it is that small, I don't like this, but anyway, if that strip, if I take a small strip from here, and that is very small, consider that a small strip I take from here is this, it is flat. So the delta A is flat, and that delta A has a direction, that is delta A has a direction, the direction is called n vector. N is a unit vector. If I take a small region here, if I take a small region here, very small, delta A, very small, it is that small that you can't see also, that much small. So that will be considered as flat region rather than round region. Now, if I magnify through magnifying lens, it is coming like this. Now, that region has a area vector. Consider that area is n vector. N vector. So, what is the surface integral for that delta A? That is capital F dot n vector, because n is the unit vector along that, delta A into delta A. What is the work done for any vector along I-axis? That vector is capital F, then capital F dot I vector into the length for which you are trying to calculate the work done. If I take I vector to L, it becomes L vector, which has direction of I and magnitude of L. Similarly, if I have a vector field capital F, if I have a vector field capital F, and I am trying to calculate line surface integral along a surface delta A, which has a direction n vector, that is n is unit vector, then it is capital F dot n vector multiplied by delta A, that is the magnitude. If I take inside delta A, it becomes delta A vector. For a small strip, it is delta A vector. So for a small strip, the surface integral is capital F dot delta A vector. If now I add all the small strips, then it will become summation. Summation is a sign, right? Summation 0 to n minus 1, where n number are n section I have taken, where n tends to infinite. Capital F dot delta A I equal to 0 to n minus a, delta A ith delta A. Okay, so capital F dot delta A vector on the bottom right side place I. So that is the kind of the line in the surface integral all the whole. So if I take a small strip and if I do addition, then it is as good as integral calculus. Now it is integration over full surface capital F vector dot dA vector. Boss, how easily you can say like this? A delta AI, delta A zeroth section, delta A first section, delta A second section, like that delta A n minus 1 second. Everyone has different direction. How so nicely you can say capital F dot delta A vector. How so easily you can say like this? How come? This is power of algebra, because delta A vector will be algebraic equation and algebraic vector field, and capital F is algebraic vector. If algebra comes into the picture, you keep changing x and y independent variable and your vector will keep changing. So if it comes in algebraic equation, like I am saying that I have a line, I have a line where at 0 x and y in the xy plane, when x is 0, then y is 0. I have a line. When x is pi by 4 in radian, pi by 4, then y is 1 by a square root of 2. Okay, when x is pi by 630, then I believe it is half. When x is pi by 2, then it is 1. So nice. Then he keeps on describing full. I said y equal to sin x. No, 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 not sin x. I have so many values. Because all values will be represented through a single line, that is y equal to sin x. Keep changing x and you keep getting different values. Similarly, the net surface integral of this is capital F vector dot dA vector, where A vector is algebra and F vector is algebra. Keep changing the independent variable, you will keep getting different values. That's where calculus comes into the picture. Calculus is a mathematical formulae which does the manipulation on algebra. So in the integral capital F dot dA vector would finally result into algebra only. That will be variation. And if you want the area for a particular surface which has limit, then surface lower limit to higher limit. So surface lower limit to higher limit, if you do, then you calculate the surface integral. So we have started the story of surface integral. We'll proceed on it. Okay, now consider I have a sphere. Oh, I really have a sphere. Okay, so Mr. Earth, if I if I if I push it, then it rebounds it. This is Newton's theory. Every action has an equal reaction. So if I push it, then it rebounds it. Whereas Einstein is saying that there is no way energy is lost. Energy changes its form. This is what Einstein is saying. So ball was kept and I am lifting the ball. When ball came here, ball has energy transferred from my body. Okay, and now this energy is called potential energy, and slowly this energy is getting transformed into kinetic energy. Then when it hits the ground, then this kinetic energy get absorbed by the ground. How much it absorbed, it depends upon the quality of the ground. If it is sand, then full energy sand will absorb. Energy will be now absorbed, energy will propagate into the sand and ball will be still there, because full energy it lost to the sand. If it is highly reflective, then it will take minimum energy, and okay, so it depends upon the quality of ball and the surface. And then ball will come up and kinetic energy will again transform into potential energy. If I throw it, then I push more energy to the ball. Anyway, if I take out from the ground and I have pushed energy from my body, then this has potential energy. If I push it, then I add more potential energy and kinetic energy. Okay, now it carries more energy. When it hits the ground, some energy gets absorbed by the ground. Rest of the energy, it comes back as kinetic energy, and which get transformed into the potential energy, and when it stops here, full energy is transformed into potential energy. Okay, now I have a sphere. So there is a difference between Einstein and Newton. Einstein talks about energy, whereas Newton talks about physics. One collides with other and that collides with other and he pulls him like that. Okay, what I'm not saying that the science that Newton brought is inferior to the what Einstein brought, but with Newton probably you will understand physics only. But with Einstein you will understand all possible medical science to whatever 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 you know, everything can be understood through energy science, body disease to everything. Okay, so probably every action has equal reaction will not work when someone is catching diseases, but Einstein energy theory will work thereof. You lack in energy, that's why you have disease. Anyway, there is a digression. Now consider there is a sphere. Now this sphere is centered at the origin. Now I have the origin. Okay, so this is x-axis and this is y-axis and this is z-axis. So this is the origin. Now ball is centered at the origin. So at the origin, I have kept one electrical charge whose value of the charge is q, small q. Okay, I don't remember what is the unit of the charge, but q is the net charge that I kept at the center of this sphere, and this sphere is centered, its origin is center of this sphere is exactly matching the origin coordinate, and charge I have kept inside that is small q. What is the electric field at any distance r, small r, that is q by r square. This is the basic fundamental, q by r square, and where r is emanating from the origin, it is going outward, so it will be positive. Whereas if this is earth, then earth gravitational pull is gm. G is the gravitational pull means force, gm divided by r square minus, because it is pulling toward the origin, minus. Now this charge, one electrical charge is kept at the center, it is going, effect is going outwards, so in that case it is q, small q by r square, that is the electrical charge. Consider this as a vector field, and this sphere has a radius of a. This sphere has a radius of a, where at any variation of length, that is small r, the electric field, if this is the place, if this is the place where the charge is kept, then at distance r, the electric field that is felt is q by r square. If I talk about vector, then it is exactly in the r direction. If that is the case, then I can say q by r to the power 3 into r vector, because wherever r I am taking, it is in that direction only. It has no particular x-axis, y-axis, because it is omni, spherically omni. Then it is q by r to the power 3 into r vector, or q by r to the power r square into unit vector of r, or q into r vector divided by r to the power 3. If this is the vector field, then what is the flux that is coming out of this sphere, whose, if it is something is kept inside this, then full flux is coming out, electric field is coming out of it, right? How much is the electric field that is coming out of this sphere whose radius is a? That is the question. Okay, I believe it is too long. So this is the questionnaire. So how much is the vector field? What is the vector? The vector field, surface integral is the vector field. What is the dA? I am talking about capital F dot dA vector, right? What is dA and what is dA? So dA here, if you take a spherical coordinate system, This equation is completely into the spherical coordinate system. It is in R, not in x, y, z. If that is the case, then q r vector divided by r to the power 3 dot dA vector. What is dA? If I take a small strip somewhere on the sphere, what is dA? Okay, dA, dA, if I take a small strip, area means it has two sides. One side is vertical arc and another side is horizontal arc. If you take horizontal arc and if you take vertical arc, then it will be constitute to one area. Make sense? So if I have a vertical arc and if I take a horizontal arc, then this constitute one area. Okay. Now if I take a vertical arc, if this is xy plane, if this is centered at the origin, then this portion, okay, the portion which is touching xy plane centered at the origin means upper hemisphere is up, lower hemisphere is down of the xy plane. So if I take the position where it is cutting the xy plane, there the vertical arc and the horizontal arc, if you take, then that is dA. Or other places it is same story, but it will be in algebra. Algebra takes care of things. So how much it is? Then if I take horizontal arc, if I take any radius r, any radius, a, I mean a is the radius of this sphere. Consider full a, full a. What is this arc? If we make phi angle from the vertical, then this arc is a phi, a a phi. What is its effect along the xy plane? A sine phi. A sine phi is the effect of this a along the xy plane. A sine phi theta. If I move theta, that is the horizontal arc. A sine phi theta. A sine phi theta. So A sine phi theta, A sine phi theta, and then this arc, that is A phi. If I talk about D area, delta area, then it is A, then it is A sine phi, A sine phi d theta into A d phi. Phi is the angle. Now it will be A square sine phi d theta d phi. That is the dA. It has a direction. I don't worry, because the electric vector field is along the radial direction only. So wherever I take area, it is along that direction only. So area vector, the area of the sphere, it has the same direction as the electric field. So dot product will be, has no effect now. So capital F, that is QR vector divided by r to the power 3 into now if I take for any radius, then it will become r square sine phi d theta. Now r vector is gone because dot product has no meaning, so it will transform into q by r square. Q by r square and r square gone, and it is now q sine phi d theta. So q I can take it out, and sine phi d theta, where phi is, if I take top hemisphere, then phi is from 0 to pi by 2 and theta is 0 to 2 pi. So I believe it can be calculated now. So we will proceed on this, that is how much is the net volume of the electric field that is coming out of the sphere, means whatever the unit is per second. So that we will proceed on.